the function which we need to maximize or minimize, we call it as the objective function, that is z. Any value occurs more than once, then it occurs at all the points joining these two. Now our task is to retain the common region of shading and erase the uncommon, and we call them as corner points. Vertices of feasible region are corner points, and you take corner points and put them in objective function. They told x and y greater than or equal to 0 means the graph lies in first quadrant. So one point I got on y axis 0, 60. Welcome to the session, dear students. Today we'll go ahead with linear programming problems. Minimize and maximize z is equal to 5x plus 10y subject to x plus 2y less than or equal to 120, x plus y greater than or equal to 60, and x minus 2y greater than or equal to 0, and xy greater than or equal to 0. See, dear students, the function which we need to maximize or minimize, we call it as the objective function, that is z. So keep z apart and take the conditions subject to. What are the conditions they give? X plus 2y less than or equal to 120, that is the first constraint. X plus 2y greater than or equal to 60, that is the second constraint, and x minus 2y greater than or equal to 0, third constant, and xy greater than or equal to 0, fourth constant. 4 constants they give. Now your task is to draw the graph for all 4. In every problem they'll give x and y greater than or equal to 0. It says non-negative constants. These two are non-negative constants. Non-negative constant means the graph lies in first quadrant. X greater than 0, y greater than 0 means x and y both are positive, means first quadrant. So you no need to worry about this. Now we need to draw one by one. So I'll take different colors so that you can understand better. First line, so x plus 2y less than or equal to 120. So we'll draw x plus 2y less than or equal to 120. For that, first you equate it to 120. X plus 2y equal to 120 you take. Now put x is equal to 0, you'll get a point on y axis. When you put x 0, you'll get point on y axis. In the place of x, if I put 0, 0 plus 2y is equal to 120, and 2y becomes 120, or y is what? 120 by 2. 120 by 2 is how much? 60. So you got y value 60. So one point you got. That point we say A is x comma y. Always we should write x value first, then y value. So x value 0, y value 60. Now you got first point. What is the first point? 0, 60. To draw any line, minimum 2 points are required. So first point A you got, and put y equal to 0. If you put y 0, x plus 2 into 0 is equal to 120, or x is equal to 120 you got. So now b is again x comma y, and x is equal to what? 120, and y is what? 0. So you got 2 points. Now we'll sketch the graph of it. I'll just draft a graph, then we'll take scale and we'll do it. So now this is y axis and this is x axis. I'll take only first quadrant because they told x and y greater than or equal to 0 means the graph lies in first quadrant. So one point I got on y axis 0, 60. So I'll take 1 centimeter as 10 units. So scale let us assume 1 centimeter on x axis and y axis is equal to what? 10 units. On x axis as well as y axis we'll take this scale. So if I take, this is 10, 20, 30, 40, 50, 60. So this is one of the point, that is A. This is at 60, A, 60, 0, and B, 120, 0. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Suppose say this is the point called 120. B 120, 0. Now stretch a line between these two. So stretch a line. I am using a color here to make you understand. So in purple color, let me draw a line between AB. So A is this point. A is what? 60, 0. A is 60, 0. And B is another point. Point on x-axis is B, 120, 0. Dear students, to draw any line, we need minimum 2 points. Now stretch line between 2 points. This is the line. Now we need to do shading. So now we need to do shading. So how to shade the region? So they told x plus 2y less than or equal to 120. Less than means generally shade below like this. Logic is substitute the origin. You know, this point is called as origin. So we'll see whether origin lies. In the place of x and y, put 0, 0. 0 plus 2 times 0 less than or equal to 120. 0 less than or equal to 120. Is it true? 0 less than 120 is true. 0 is a number which is less than 120. If you get true, go towards origin. So I should shade towards what? Origin. So first line, first constant I have drawn and I have shaded. Now similarly, second constant. What is second constant? X plus y greater than or equal to 60. So x plus y greater than or equal to 60. So x is equal to 0 you put, so you'll get y. I told first you should take equal to 60. X is 0 if you put, you'll get y 60. So one of the point A, B we have covered, so C we call it as x comma y. What is the x value? X value is 0 and y value is 60. And put y is equal to 0 and you will get x. X will become what? 60. So D is what? 60 comma 0. You got 2 points, 0 60 and 60 0. 0 60 0 60. It's a point on x axis, y axis. 0 comma 60. Always point on y axis will be 0 60. And your D value, so D value is also same. So your D value, whatever way, sorry, C value, here if you see, C is also 0 60. C is also 0 60. So C and A both are same. C and A both are same. So this is also C. We can also call this a C. And D is what? Value you got? D values 60 0. D value is 60 0. 10, 20, 30, 40, 50, 60, 60 0. This is D. CD. So now I'll get one more line between C and D. C and D both C and D. Now I need to shade again. Now our task is to shade, and they told greater than. You can see this is greater than. Greater than means shade above. Generally greater than means what? Shade above. Means here if you put origin 0 plus 0 greater than 60 is false. Is 0 greater than 60? This is false. That's why I should shade above. So shade it above. So purple line shading down and green line shading up we have done. Purple line what we have done? We have shaded below. So like this we shaded, right? But green line we have shaded above. Green line we have shaded above and purple line we have shaded below. So two constants I have done. So to make a difference I have used two different colors. Now third constant x minus 2y greater than or equal to 0. One of the important condition. So now we'll use another color to do it. X minus 2y greater than or equal to 0. So now we need to draw x minus 2y greater than or equal to 0. Dear students, in my first class I have drawn type of graphs. So in type of graphs I taught you, if you have x and y term and if constant is 0, then it is a line passing through origin. So very interesting. So first I will take x minus 2y is equal to 0. I will take x value 0. If I take x value 0, I will get minus 2y is equal to 0 or y is also 0. So one point we got 0 comma 0. 0 comma 0 generally we name it as O. And dear students, here if you put y 0, again you will get x also 0. So both the points will get only one point, that is 0 comma 0. By having one point you cannot draw the graph. So if I want to draw the graph, minimum this is x axis and this is y axis, minimum I need 2 points. I got 1 point, that is 0 comma 0. Now how to get the other point? In order to get the other point, we will solve the equation. See here x minus 2y equated to 0, or you will get x is equal to 2y, or so x value is 2 times y. So you choose, see all are in multiples of 10, choose any particular x or y, you will get x. I will take y. Well, let us assume y is equal to, say, I will take 30 or okay 20 I will take, y is 20. Then what is x? X will become 2 times 20. 2 times 20 is 40. So when your x is 20, y is 40. Any one possible point you can take. I call it as O, A, B, C, D we have done, O, E. E is a point where x value is 10, 20 and y value is 40, 10, 20, 30, 40. 10, 20, 30, 40. So this is 40 and this is 20. So this is the point E. Now stretch a line between these two. But interesting is how to shade. So now they told greater. Greater means not above always. Here origin is on the point. So choose any point. I always choose one point on the x-axis. Can I say 5, 0 lies on x-axis? Now put 5, 0 in LHS. If it is true, go towards x-axis. Choose any point on x-axis. Point on x-axis will be in the form x, 0. Substitute in LHS. If you get the statement true, go towards x-axis. Otherwise, go away from x-axis. So now what is the statement? X minus 2y. The statement will take the given statement. They have given, what is the statement given? They have given x minus 2y greater than or equal to 0. In the place of x and y, put 5x, 5, 2 times 0, greater than or equal to 0, 5 greater than or equal to 0. Is it true? So now 5, 2 zeros are 0, 5 greater than or equal to 0 is true. So therefore, I should shade towards this 5, 0 means I should shade below. Shading is below. I hope all of you got it. So now 0, 0, 20, 40. So 0, 0, this is 0, 0, 20, 40. So x value 20, y value 40 somewhere here. So this is the point of intersection will be here. So now stretch a line between these two. This is the, now shading should be towards what? This. Okay. So now we have got the graph. I got the graph, but important is we have 3 different lines. Common region of shading you should pick. See here, purple line I have drawn, I have shaded. Green line I have drawn, I have shaded. And blue line I have drawn and I have shaded. So now our task is to retain the common region of shading and erase the uncommon. See here only purple is there, I'll erase it. Here only blue and purple is there, I'll erase it. Here only, see here in this region only green and purple is there. But here green, purple, blue, all 3 are mixing. So this region, call it as feasible region. Feasible region, so you can name it, and this common region of shading is feasible region. So draw each line, shade each line, and only one line is there, one line shading is there, erase. Only 2 are mixing, erase. If all 3, because they gave 3 constants, if all 3 constants are mixing, retain, that is feasible region. What is feasible region? Common region of shading. After you do that, so first line when you draw 0, 60, 120, 0, and second line 0, 60, 60, 0, third line 0, 0 and 20, 10. So we'll get this. So this is your feasible region. Here blue line, or all the regions, all the shadings will mix. This is a common region. We call it as what? Feasible region. So the vertices of feasible region, this vertices of feasible region, we call them as corner points. So one of the corner point is A 60, 0. Other corner point B 40, 20. C 60, 30. D 120, 0. So 4 corner points you got. What are they? B, C, D, A. So feasible region, first you should mention what is feasible region in terms of feasible region is A, B, C, D, A. The common region of shading, this region. And we call them as corner points. Vertices of feasible region are corner points, and you take corner points and put them in objective function. Till now we have not used objective function. This is objective function. Now you substitute the corner points in objective function. So now A, B, C, D, substitute them in Z. So substitute means what? A value, put it here. Means in the place of Z, what is Z? 5x plus 10y. So A means 60, 0. In the place of x put 60. In the place of y put 0. Z is equal to 5 into 60 plus 10 into 0. 6 5 is 30, 300. So you'll get 300. So by substituting this, now substitute B in Z. If I substitute B in Z, so Z is equal to 5 into, in the place of x put x coordinate, in the place of y put y coordinate, 5 into 40 plus 10 into 20. So 5, 4 5s are, this will become 200 plus 120, 20 10s are 200, sorry. 200 plus 200, that is 400. So fill that 400 here, then put 60 30, you'll get 600, 120 10, you'll get this. So like this you fill, means substitute the corner points, and you get the value of z. Check where it is minimum, where it is maximum. 300, 400, 600, 600. So minimum value is 300. Maximum value is 600. 600 occurs at two places, but 300 occurs at only one place. So we'll say the minimum value of z is how much? Minimum value of z is 300. Where it occurs? It occurs at 60, 0. And maximum value occurs at C and D. And you should not write maximum value occurs at 60, 30, 120. So maximum, if any value occurs more than once, then it occurs at all the points joining these two. So maximum occurs at 60, 30 and 120, 0. So you should write maximum value is 600 that occurs at all the points joining this C and D. Remember students, if maximum occurs at more than one point, you should mention it occurs all the points joining these two. So if you draw a line joining C and D, all points also gives 600, 600. That is the fact of linear programming. So now minimum value is 300, occurs at 60, 0. Maximum value 600 occurs at all the points joining C and D, you should write. Don't forget it. Maximum not only occurs 60, 30 and 120, 0. It also occurs at all the points between C and D. If you stretch a line between C and D, all the points on the line joining C and D will give you 300. That's why you should write that statement. I hope all of you got it. So first you should draw each constant and shade, and finally retain the common region. We call it as feasible region. Vertices of feasible region, we call them as corner points. Put the corner points in Z. So every point you put it in Z, you'll get the values. And minimum value in the table you see, that is the minimum. Minimum is 300. Z is equal to minimum 300 and occurs at 60, 0. Maximum 600 occurs at all the points joining 60, 30 and 120, 0. Here many students will do mistake. They'll tell maximum occurs only at these 2 points. No, not only these 2 points. If you stretch a line between these 2 points, any point will also give you the same. So that's why you should mention maximum value occurs. So maximum value here, occurs, maximum value of z is equal to 600 occurs at all points joining this. Similarly, one more question. Z is equal to 3x plus 9y subject to x plus y greater than or equal to 10, x plus 3y less than or equal to 60, and x less than or equal to y, xy greater than or equal to 0. So first constant x plus y greater than or equal to 10, take x plus y is equal to 10, put x is equal to 0 in the equation. If you put then 0 plus y is equal to 10, you will get y is equal to 10. So group it as point A. Point A means what? X comma y. Always 0 comma 10. 0 comma 10 is a point on what axis? Y axis. When you draw a graph, so on x axis and y axis, on y axis we got 1 point 0 comma 10. We named it as what? A. Further put y is equal to 0 in the same line. So you will get x plus 0 is equal to 10. You will get x is equal to 10. You will get point B. B is what? 10 comma 0. So another point you got, that is 10 comma 0. That is a point on x axis. Now stretch a line between these two. Now we need to shade this. In order to shade this, they told greater than or equal to. Greater than or equal to means, see, x plus y is equal to 10. Greater than or equal to they mentioned. So shade above. I told you the logic. If you substitute the origin, it becomes false. Suppose x plus y greater than or equal to 10. If I put 0 plus 0 greater than or equal to 10, 0 greater than 10 is false. So 0, 0 does not lie. So this 0 does not lie means, so shade away from 0. If it is true, go towards 0. So now always greater means shade above. Next, x plus 3y less than or equal to 60. Second line is what? X plus 3y less than or equal to 60. So put x is 0, so 3y becomes is equal to 60, y is 60 by 3, so 3 ones are 3 20s are, y is 20. So you got one of the point, name it as c. C is 0 comma 20, x comma y, and put y is 0. If you put y is 0, x is equal to 60 you will get. So you will get another point d. D is what? 60 comma 0. So now plot the, see, 0 20 60 0, 0 20, 0 20 is after this. This is c. D is what? What is d value you got? Sorry, what is d value you got? 60 0. 60, 0 means after this. This is D. So stretch a line between this. Now shading. So they told less than means shade below. Shading goes below. Then third line, x minus y less than or equal to 5. X less than or equal to y. So dear students, x less than or equal to y, here we don't have constant, so it passes through origin. The third line, whatever we have taken, that also passes through x equal to y. X equal to y passes through origin. Y is equal to x is a line which makes equal intercept. Suppose if you take x 10, y is also what? 10. So shading, in order to shade, put x less than or equal to y, put 5 comma 0. So 5 less than or equal to 0 is false. So shading of the line, so if I draw a line will be like this, and shading is away from this. Now one line, x value, see origin is 1 point, the other one if I take 10, this, it intersects at 2 points, and shading I should do above. Now all the three shadings will mix in this region. So you can see red line shading is here, and purple line shading is here, and yellow line shading is also here. So all lines mix at this. So we call this as feasible region. So this A, C and P, Q are any point of intersections. Point of intersection from the graph you have to pick, and this we call it as what? Feasible region. And now we'll plot the graph. When you plot the graph, you'll get this region. See, I told you in my diagram. So in my diagram, so one of the line we have taken, if you see, this is a red line. This is AB. AB is shaded above. So AB, this is A, and this is B. This is shaded above. Common region will retain. And then we have taken the purple line, that is CD, shaded below. CD, this is C in the diagram, and actually this goes towards like this, and D, so it will be shaded here. And origin, this is shaded, so like this we'll get feasible region, this and this. Vertices of feasible region A, B, C, D we named, we call them as corner points. Substitute them, A, B, C and D. Substitute A in Z, means in the place of x put 0, in the place of y you put 10. 3 into 0 is 0 plus 9 into 10 is 90, so it will be 90. Similarly put 5 comma 5, 3 5s are 15, 9 5s are 45, add it will become 16, and 15 you substitute, you will get 180. 0 20 you substitute, you will get 180. So here Z minimum, what is the minimum value of Z? Z minimum is 60, occurs at only 1.5 comma 60, occurs at what? Occurs at 60, occurs at 5 comma 5. And maximum, what is maximum value? Maximum value is 180. We have only one maximum value, but it occurs at what? It occurs at, I told you in last case, it occurs at all the points joining 15 and 020. If any optimal value occurs at more than 1 point, then it occurs at all the points joining these two, C and D. This is the conclusion. So by this, so here I've mentioned it. So dear students, sit and practice more graphs. I'll see you in my next session. Thanks for attending. Thank you.